Hey everyone, welcome back to the channel. Hope you all are doing well, and today we are going to discuss another problem from our SD sheet, and the topic we were discussing was binary trees. So I'll show you the problem statement. So have a look. Print left view of a binary tree. This is what we are going to discuss today. A very good problem. It has been tagged easy, but it's a very good fundamental problem. So let's start off. Let me just check if I'm live. Yes, I think we are. Okay, so let me explain you the problem statement. A very good question. So we can take any example, hardly matters, but okay. So you have to print left view of a binary tree. What does this mean? So let's say this is your binary tree, which is 1. We have 2, 3, 4, 5, 6, 7, and what else we have? We have 8. Okay. So when I say you have to print left view of a binary tree, that means just imagine you have a lens looking from this direction. Okay, so if you have a look from this direction, okay, what are the nodes you are going to see? So you need to understand one thing, that all the nodes that are occurring at the beginning at each level are the nodes that I can see, and the nodes behind them will not be seen clearly, right? So if I see what is the first node that I'll see, you can see from top to bottom. Anyway, you just have to check that if you see from left view, what are the nodes that you are able to see. See, I can see 1, which I'm writing here. Then the next node I can see is 2. Will you be able to see 3? 2 will be overshadowing 3, so we won't be able to see 3 but 2. Then at this level you'll see that first element to occur is 4, so exactly that's what I'm going to see, and the rest of them will be hidden. So next is 4, and then from here the first node I'll see is 8. So these are the nodes that you will be able to see, and that's what you have to print or return in an array list, which will store the elements that you can see from the left side of a binary tree. Got it? So how can you do this problem? Again, you need to, whenever you solve such problems, or these are the basic ones, we know that binary trees have been all about traversals and recursion and backtracking. So what kind of traversal here will help you get your answer? So if I see, I know that I have to anyway get the first node of each level. Either there's one way you go level order traversal, right? But there is one other way as well, which we are going to discuss, which will be a recursive approach. Okay, I'll drop a hint. If you want to go level order traversal way, that will be an iterative approach that can be solved using iteration. So think of it using an extra data structure. How can you do it? So let's discuss the recursive one. So the idea here is that you will create, let's say this is your helper function, okay, which will be taking the root node, an array list which will be storing these values, which finally will be our answer, that are the nodes that we can see from the left view. And the level, since it will be a recursive approach, this level is a parameter that is going to be changing, right? So let's see, initially when I'm passing 1, this is the root node, right? My level is 0. Right now my level is 0. Okay, now the next one is the node that I want to have a left view of my tree. So I'll prefer to go root, then left, and then its right node. Okay, that's how I'm going to process. So what kind of a traversal is this? Root and then its children. So this is pre-order traversal. Okay, cool. So first you see that when you are giving this root to your helper function, okay, the level that you are at is level 0. Right now your array does not contain anything. Your array is empty. Array list is empty right now. So when you encounter a node whose level you know it's 0 level. Right now it is equivalent to the size of your array. There are no elements in your array. So that means this is the first time you are coming at this level, at which the level which has not been already filled in your array, because that is determined by the size of your array. You'll see what I mean by this when we go to the other recursive calls. Okay, so I found 1. I'll insert 1 in my array and go ahead. Right now the size of my array is 1. The next node that I will come is this left node. Now I am at 2. So when I come at level 2, when I come at node 2, this is the child of 1, so obviously one level should be increased. So this level is 1 right now. I will check what, just give me a second. What I'm going to check is, what are you going to check is that this is the next level, and the node that you are going to insert in your array, with that the size is also, right now the size is 1 and the level is also 1. So when you see that the size of your array is equivalent to the level of the next node that you are going to enter, this means you will be entering this level into your array for the first time. So I will add this element into my array, right? So this 2 enters here. Next node will be the left of, we are going recursive way, so root, left, right. So first all the nodes that I am checking here are these root nodes, then their lefts and then their right. So now I'll eventually go to the left of 2. Now when you see I am at 4, the level will be increased by 1 because this is the child of 2. So level will become 2. Now I check what is the size of my array. If the size of my array is equivalent to the level of my next node that I am currently at, this means that this is the first node of that level which I am going to enter into my array. So I will quickly add that element into my array, right? Because I am traversing in such a way that the first element that I will be at, okay, for that particular level, if that level matches the size of my array list, that means this is the first node of that level in my pre-order traversal. Okay, so the next node you will be coming at is the null node, because the left of 4 is null. Now you backtrack and you go to the right of 4. Okay, when you go to the right of 4, what was the level at 4? Level was 2. So the level for 8, each time you come at the child node, the level will be increased. So right now the level is 3. You check, is the size of your array equal to the level of this node? Yes, it is. That means for that level, which is the level 3 here, the 8 is the first node that I am getting at this particular level. You need to understand in this way. See, left view is nothing but the very first node of each level, starting from the left side, right? So this kind of thing is just telling me that if the level matches the size of your array, that means for that level you are exactly at the node which is the first node of that level from the left hand side. This is the reason we are processing this tree as root, left and then right in recursive order. Okay, so I entered 8 also. Now you backtrack, you go to 4, no child nodes further, you go backtrack, go to the right child of 2. When you go to the right child of 2, you are at 5, whose level will be 1 greater than the level of 2. So the level of 2 was 1, so the level of 5 will be 2. Now you check the level, does it match the size of your array list? No, the size of your array list is 4, which does not match it. So now you see how this level, how handling these levels with each node is helping us. Now I got to know one thing for sure, since the level is not equal to the size of my array, that means the node which might have been the first node at level 2 has already been pushed into my array. So 5 is not the element that I might see from the left view. Got it? So you backtrack, you do nothing, you don't add it, you backtrack. Now this is done. Now you go to the right of 1, which is 3. So 3 will be, the level of 3 will be 1 greater than the level of 1. So the level of 1 was 0, so 3's level will be 1. You check if this level is equal to the size of your array, which is not clearly the case. So you are not going to push it. You go, then recursively you go to the left child of 3, which is 6. The level of 6 will be 1 greater than level of 3, which is 2. Again 2 is not equal to the size. You backtrack, go to the right child. For 7 also the level is going to be 2, which is not, matching the size of your array, you backtrack, and once now you have done all the calls will be removed from your recursion stack. Finally you ended up with an array list that has 1, 2, 4 and 8, and that was what we wanted. I hope you understood the problem statement. So since we are taking extra space of array, if for example you have only a skewed binary tree like this, or skewed tree 1, 2, 3, 4, so it can take up the space equal to the number of nodes also, on. So anyway, space complexity is going to remain on only, and time complexity is, since we are traversing through each node at most once, big O of n is your time complexity. Okay, so let me know if you guys have any doubts. Now I will move to the code and let's code it. So as I told you, we are going to take a helper function because I want the parameters level which will be changing for every recursion call. That is why that's a changing parameter. And other one is the array list, which will be storing our answer for each subsequent recursive call. So this function will not help me, so I'll just make a call to my helper function. For that, first I'll create an array list. Of type integer, that because that's the demand of this function. They want return type to be an array list. So arr new okay, then I'm making a call to my helper function by passing root into it. Then I'll be passing this arr int level, which initially will be 0. Your level will be 0 and root node will be root. That's all, and return arr. Let's form the helper function, create it, void helper, void type, because anyway my answer will be stored into my array list, which I will pass as an argument here. So node root is the first parameter, then I have array list of type integer arr int level, correct? Okay. Next thing, if what would be your basis condition? If root is null, your level is what? You don't have to actually return literally, you just return. That is where you return. Fine. Then the next thing we are doing is we are checking if the level matches the size of your array list. That means this is the first time you are coming at that level, and this is the first node of that level starting from the left side. So you should be adding it to your array list. So arr.add that node's data. That node will be called by root, means that will be a root dot data. You should enter into your array list. Otherwise, you go and make call to the left side, helper, make a call to root dot left, and when you are making a call to children, right, your level will be 1 greater than yourself. So arr will be as it is, your level will be level plus 1. Same thing for right side. When you are making a call to your right side, the level will be 1 greater than yourself, and you will be passing root dot right. Fine, arr, that's all. Let's compile and submit it. Fine. Do you guys have any doubts? You can ask me, and that was all for this problem. If not, we will wrap it up. Okay? So that was all for today, everyone. See you all in the next lecture. Bye bye and take care.